So the options are A is ring like this plus SbCl5. B is your 5-member ring bromo plus AgBF4. Option C is compound like this. Here is a phenyl, here is phenyl. So here we have C double bond O phenyl plus NaH. Option number D is your 5-member ring cyclopentadiene, adding your sodium to it. So now the question is reaction or reactions. The question is more than one option correct, right? Reaction or reactions that result in the formation of aromatic species are. Which will form aromatic species? Now, one by one. In the first option, SbCl5, take out this chlorine. It forms a compound like this. In the second case, AgBrF5, take out this bromine. So this compound is formed like this. In the third case, sodium hydride is a base, it will abstract hydrogen. So कौन सा hydrogen abstract करेगा? This hydrogen which is present here, that is the most acidic because of the presence of the C double bond O electron withdrawing group. So it will take out this hydrogen. So negative charge will appear on this carbon. So the compound formed is like this. Negative charge here. And in option number D, we have a sodium added to this cyclopentadiene. Then it will take out H from here, one hydrogen from here. So we get a compound like this. So these four compounds, these four products are formed. Now we will see which reaction will give aromatic. Just compare their, check their aromaticity. First compound is a 2pi electron, is aromatic. This is 4pi electron, anti-aromatic. This is again 4pi electron, again anti-aromatic. Last one is 6pi electron, is aromatic. So your correct options are A and D. तो क्वेश्चन जो है वो एरोमेटिसिटी के बेस पे ही है, थोड़ा सा उसको घुमा के किसी फॉर्म में क्वेश्चन जो है वो पूछ लेते हैं. नेक्स्ट क्वेश्चन है जैम का 2015 का क्वेश्चन नंबर 7. So this question is from question 7 JAM 2015. Question is, which of the following is are aromatic in nature? Aromatic in nature. So in this compound or so actually so 13 question 13, which of the following aromatics or are aromatic in nature? तो 4 compounds दिए हुए आपको. फर्स्ट इज this is your P. Second is this is your Q. Third is your R, and last one is C. say here the negative charge is S. बहुत easy है. Options हैं. A option is P and Q. B option है P, Q and R. C option है R and S. और D option है Q and S. So very easy. First is this is sp3, we know, non-aromatic. Second is 6 pi electron, is planar, completely conjugated, aromatic. Third is again 8 pi electron, non-aromatic. And last is again 6 pi electron, is aromatic. Very easy. So correct option is your Q and S. So option D, correct. Okay, next question of JAM 2019. Question number 8. Among the following number of aromatic compounds. So among the following number of aromatic compounds is R. So which compounds दिए हैं? We have to find how many out of them are aromatic. So first दिया हुआ है oxygen here, double bond over here. Second is your this compound is given, and third is BH is given. Fourth is this one, here methyl group is here, and last is S. So simple question है, we have to find out which out of the following are aromatic. First compound, so here is a lone pair of electron. When there is a lone pair of electron, one double bond is present in your p orbital, other is present in sp2 hybridized orbital. So this is in p. So there are this carbon, because it has a positive charge here, is sp2 hybridized. So overall in this molecule we have 6 pi electrons. So this is aromatic. Come to second. This nitrogen has a lone pair, this nitrogen has a lone pair, this will move like this will move like this. So both the nitrogen are sp2 hybridized because they are attached with, this nitrogen is attached with this sp2 hybridized, this carbon is also sp2, so this nitrogen is also sp2 hybridized. So how many p electrons are there? It means this pair of electron is also present in p. ये भी p में है क्योंकि तक इसने डबल बॉन्ड नहीं बनाया. एक p है, एक p है, तो we have a 6 pi electrons. So this compound is also aromatic. Next, to move to the next compound. Boron is sp2 hybridized. All the atoms are sp2, but it has only 4 pi electrons. So this compound is your anti-aromatic. Last one, this nitrogen has a lone pair. This nitrogen also has a lone pair, but this is present in sp2 and this is present in p. So we have 6 pi electron. So this is also aromatic. And last one, sulfur has a 2 lone pair. So one lone pair is present in p. 2 plus 4, again 6 pi electrons. So this is also aromatic. So out of these 5 compounds given, 4 are aromatic. The answer is here 4. Then we will move to next question. Question number 9. That is also of IIT JAM. So this is a JAM 2013. Question is, a compound is given. हम पहले पिछले लेक्चर में किसी में डिस्कस भी किया हुआ है. This compound is called calicine. This compound is called calicine. तो कह रहा है calicine is polar hydrocarbon with high dipole moment. High dipole moment. Most stable dipolar canonical structure is तो हम ऑप्शन ए लिखेंगे, सीधी जो स्ट्रक्चर है उसकी मोस्ट स्टेबल वो बनाएंगे. अब हमें क्या करना है इस केस में, वी हैव टू शिफ्ट दिस डबल बॉन्ड वन साइड. इस तरीके से शिफ्ट करेंगे दैट वी गेट द स्टेबल कंपाउंड. टू वेज आर देयर जनरली, इफ वी लाइक दिस और लाइक दिस. So this is say A, this is say B. When we move the electron pair like A, so what will form? We get this compound here, negative and positive charge. And when we move the electrons like B, then we can draw its structure like this. This is negative, positive. Now we will compare the stability. This ring is 6 pi electron, is aromatic. This ring is 2 pi electron, is also aromatic. So overall compound is aromatic. In this case, this has a 4 pi electron, anti-aromatic. This has 4 pi electron, anti-aromatic. It means आपका जो डबल बॉन्ड का इलेक्ट्रॉन है, they are favorably shift like B. So your most stable canonical structure, that will be this. So it has a high dipole moment due to the presence and positive and negative charge. So this was the question in JAM 2013. Now next question is question number 10. That is also from JAM IIT. Question is of JAM 2011. Question is the product P and Q in the following reactions are. In the following reactions are. Reactions are given, and first is this compound treated with the NaNH2. This is a base which abstract a proton. Second structure given is one chlorine here, one chlorine here. And we added a silver nitrate. Silver nitrate will take out chlorine. Q. Now these two reactions are given. We have to find out P and Q. Options are option A. So just write the options first. This is P, and this will be your, I can say, Q. Option B, this will form as a B, same as first option, and This will form here B. Option C is this will form, and this option D is, no, very easily you can find the answer if you know hybridization and aromaticity well. This and green here. So these four options are given. We have to find the structure of P and Q. So simply this is a base, it can abstract a proton either from this carbon, this is 1 degree, or from this carbon. So options से पता चल रहा है कि या तो हाइड्रोजन यहाँ से निकला है और यहाँ हाइड्रोजन जो है वो यहाँ से गया है पॉजिटिव, it's negative hydride ion. So now we just find from the option just find which are stable, which are aromatic. That will be the answer. This is non-aromatic, this is non-aromatic, this is your anti-aromatic, this is 6 pi electron aromatic, this is 2 pi electron aromatic. So all the other options they have non-aromatic or anti-aromatic. Now only option C has either it has both the products are aromatic. So your correct option is C, in which we got two compounds which are aromatic. The sodium hydride, that abstract base, that also abstract hydride ion, so produce this molecule. No other options have a stable products. So this is a question basically upon the aromaticity to find out the product, because in this compound we have a two options, that silver nitrate may take out this chlorine or may take out this chlorine. So when we take out this chlorine we get this molecule that is stable. When we take out this chlorine we get this molecule. This molecule is your aromatic compound, but the other compound is when you take this chlorine and you get this molecule, and this molecule is non-aromatic. अगर यहाँ से क्लोरीन जाएगा you will get this non-aromatic, ये क्लोरीन जाएगा you will get this or this, that is aromatic. So यहाँ पे जो इसने positive charge लगा दिया, carbocation is given, and negative charge means this 6 pi electrons are there, so this is aromatic. So obviously P product found will be this and Q product found will be this. Next question. Next is CSIR UGC JAM, UGC NET में से कुछ questions. So question number 11. Most acidic species. Directly this is question from GATE. Also appeared in CSIR UGC NET and GATE 2008 में भी ये question जो है वो आया था. Question is most acidic species. तो यूजीसी नेट में भी क्वेश्चन था सेम ही क्वेश्चन जो है वो गेट 2008 में भी आया था. तो चार ऑप्शन थी. ए इज लाइक दिस, बी ऑप्शन is like this, C option is like this, and D option is like this. Here is a hydrogen in positive charge and here we have n-dimethyl. So these four options are there. So this is a question of GATE 2008 as well as UGC NET. So very easy. इसमें भी यहाँ पे पॉजिटिव चार्ज आएगा. So we have to find which is more acidic, means which compound can easily give H positive ion. तो वो compound H easily देगा which is going to be stable. So just remove the H positive. When you take out one H from here, it will change into like this. When you take out one H from here, it will change into like this. Take out one hydrogen from here, it's already aromatic. So we get, if you remove this, you get pyridine. If you remove hydrogen from here, it also get this structure like this. Now, analyze the product formed. In first case, product formed is non-aromatic. So this is not acidic. ये H दे भी देगा, it will not go towards the stability. Second, this compound is non-aromatic, and when it give H, it change into aromatic, acidic. This compound already is aromatic. When it give H, it remain aromatic, no change. This compound is aromatic, and when it give H, it remain aromatic. So where the feasible process is there? In B, because this compound is non-aromatic, but when it give H, it means it has a more tendency to give H positive ion. So because why it is a more tendency? Because it's going towards stability from non-aromatic to aromatic. So the most acidic species is B. Next question. Question number 12 again from CSIR UGC NET. Question 12. CSIR December 11. Among A to C, the aromatic compounds are so A is like this, B is here like this, B, and C is here. It's naphthalene. Options are A, B and C. Option B, A and B. Option C, B and C, and option D, A and C. So your correct option is B and C, because A is not flat. When you put here some group like methylene or oxygen, this oxygen is above the plane. This oxygen that helps to keep the two rings on one plane and make it aromatic. It has a 10 pi electron, it's aromatic. Oxygen is above the plane that helps to keep the two rings in one plane. So it becomes flat, cyclic, and is fulfill the Huckel's rule, so it is aromatic. Again, naphthalene is 10 pi electron. We know both the rings are in one plane. That is also aromatic. So option B and C is correct. So option C is correct overall. Next question. Question number 13. Question 13. That is from CSIR. December 14, the compound that is anti-aromatic. The compound that is anti-aromatic is option A is like this. B is like this, so bicyclic compound. Option C is this, and option D is this, which is anti-aromatic. So we will find the aromatic character first. Cyclic completely conjugated, this boron is also sp2, but it has a 4 pi electron, so it is your anti-aromatic. This has 6 pi electron, aromatic. This carbon is sp3 hybridized, non-aromatic. And when you move like this is quasi-aromatic. It gets positive charge, so it's a 2 pi electron, so you are quasi-aromatic. So your correct option is A, that is anti-aromatic. Okay, next question number 14. Question number 14 is from GATE 2006. Correct order of basicity. Correct order of basicity of the following. First चारों कंपाउंड लिख लेते हैं. First is your pyrrole. Number 1. Number 2 is like a 6-member ring. It's like this. This is actually indole. Benzene fused heterocyclic. This is number 2. Third is your pyridine, and fourth is piperidine. So options are 4, 3, 2, 1. D option 3, 4, 2, 1. C option था 4, 3, 1 and 2, और D option था 3, 4, 1 and 2. तो अब हम इनको बेसिक स्ट्रेंथ के हिसाब से अरेंज करेंगे. तो फर्स्ट इज basicity again depends upon the lone pair or nitrogen. Which nitrogen can easily donate lone pair of electron? That is most basic. We know that in all these compounds, say in first case this lone pair is present in p orbital, get involved in resonance. In the second also this lone pair is present in p orbital, but this lone pair can be easily donated as compared to this. Why? Because this molecule has already a ring that is aromatic, sufficient aromatic. And so 2 has a more, you can say that 2 has a more tendency to give electron as compared to 1. So 2 has a more electron tendency as compared to 1, like here and here. So option A and B, C and D तो cut हो गया. Option D, 4, this is piperidine, this is number 4 compound, has a maximum tendency to give electron. Now, this pair of electron is present in sp2 hybridized carbon, but this pair of electron is present in sp3 hybridized carbon atom. So we know that it's difficult to remove the electron from sp2 hybridized carbon. They are more penetrating because it has a more s character. So electron which is present in sp2 hybridized orbital are more close to the nucleus. They are more penetrating. It's not easy to donate as compared to sp3 hybridized orbital. So of course, your compound number 4, that is the most basic, then 3, so your option A is correct option. Compound 4 is most basic, compound 1 is the least basic because lone pair get involved. Compound 2 is less, is more basic because it can donate. अगर ये donate करता भी है, then its ring, benzene ring remain as aromatic. That's why its basic character is more than pyrrole. ये था question. After that, question number 15. क्वेश्चन नंबर 15 ये है हमारा गेट 2008 का इजी क्वेश्चन है। कंपाउंड दैट इज नॉट एरोमेटिक, कंपाउंड दैट इज नॉट एरोमेटिक इज, चार ऑप्शंस हैं। ए कंपाउंड इज हियर, this, B is with a negative charge, C is 5-member ring, and your D option is 8-member ring like this, and we have here is a negative charge, here is also negative charge. तो ये चार ऑप्शंस थी इसमें, तो हमें बताना है विच इज नॉट एरोमेटिक। तो हम इसमें से एरोमेटिक फाइंड करेंगे। सो वन बाय वन, फर्स्ट कंपाउंड हैज अ 6 pi इलेक्ट्रॉन, so this is your aromatic. Second compound is 8 pi electron, is a anti-aromatic. Third compound is 6 pi electron, aromatic, and the last compound is this pair and this pair. They are get involved in resonance, and this carbon is sp2. So we have 10 pi electrons. This is also aromatic. So आपका correct option क्या था? B, which is not aromatic. Then next question, question number 16. Which gives white PPT of AgCl? Which gives white PPT of AgCl? ये भी गेट का क्वेश्चन है। तो इसमें तीन ही ऑप्शंस हैं, एबीसी, और आपको कंबाइंड में इसकी ऑप्शन दी थी, जैसे ये दिया कंपाउंड। एजीसीएल के प्रेसिपिटेट कब देगा? जब हम इसको सिल्वर नाइट्रेट से ट्रीट करेंगे। बी जो था वो ये था, सीएल हियर, इसमें भी AgNO3 डाला है। सी जो था वो था आपका 6-member ring, sorry, it's not a 6-member ring, it's 5-member ring with chlorine here, and when you add AgNO3. So what compounds are formed when we remove this? First case, remove this chlorine, you will get positive. Second, remove both chlorine, you will get dication. Third, remove this, you will get cyclopentadienyl anion, cation. So now see here, character, aromatic character. First compound is aromatic, 2 pi electron. Second is also 2 pi electron, and third is 4 pi electron, is anti-aromatic. So your correct option which give white PPT, first and second.